Welcome to the December 2020 General Meeting of the Chicago Astronomical Society. Our speaker tonight is David Fuller. Dave is a longtime amateur astronomer, telescope builder, and he is host of the YouTube Eyes on the Sky channel. And he has a series called Telescopes on the Sky, which is geared toward the beginner, but is useful for long-time stargazers as well. Dave has developed a list of deep space objects from the MESSIER, NGC, IC, and double star catalogs. And he's compiled a list of deep space objects that are suitable for viewing through light polluted skies, such as we have here in Chicagoland, and through telescopes of various sizes, including small telescopes. So Dave, why don't you fill us in, educate us, and take it away.
Thank you so much, Jim. I appreciate that. I am going to share my screen, but I'll also ask that hopefully Wayne will be able to confirm for me that I've got this getting ready to share. So I need to, I thought I had it. Nope, apparently I didn't. There it is. That one. Okay. So we got that. And can everyone see that okay?
Looks good.
Excellent. Okay.
Yep.
So as Jim mentioned, I've been working on developing this list called Telescopes on the Sky, which kind of plays on my YouTube channel name and my website name of Eyes on the Sky, really to help everyone be able to find things with telescopes in the night sky, particularly through light pollution, because that's really something that kind of applies to all of us. So to bring things back just a little bit, where it started was I began my journey with telescopes just using a very small 50 millimeter f10 refractor that was on a terrible mount that had awful eyepieces and an even worse finder scope, as I'm sure some of you may be able to relate to. But I persisted nonetheless, and I was fortunate in using that particular telescope because I was able to have access to some relatively dark skies to use it under, so I could find some things and look at objects. And I was fascinated with astronomy ever since I was a kid. So just being able to see anything was wonderful to me. And I was excited to be using that. But as I got older and began expanding what I was able to try and look at through larger telescopes, I realized, and also moved up to the Chicago area, I discovered that light pollution is the thing that we all contend with and makes it more difficult to see those objects. So to give a little bit of context, I've probably owned upwards of 50 or 60 telescopes in my life, ranging across all types, refractors, reflectors, catadioptric telescopes, and all sizes, all the way from that 50 millimeter one to a 16-inch reflector that I own now, and everything in between. And as I got frustrated by that light pollution issue, I started making YouTube videos. And the first one was this: learn how to align an equatorial mount on YouTube. And that was actually 10 years ago this last month. And it's apparently been a fairly useful video for people, because I think it has somewhere north of 700 or 800,000 views now, which is kind of surprising, but apparently that's been good. So I continued that particular journey when I realized that there's a great program out there called Stellarium, and I could help people find and see things in the night sky. So I have continued to do that both online as well as in the realm of personal outreach events, which unfortunately we're a little bit prohibited from doing at the moment. But for those 10 years, I've done outreach at forest preserves. I've done it up at in Chicago with some of my friends. I've also had the fortunate opportunity to be able to do some things in California and Pennsylvania and other parts of the country with some outdoor retailers who have asked me to help them with that too. So in that 10 years, I've learned a lot about what people find exciting to see at the eyepiece and what makes them go, wow, that's cool, that's amazing. And also what they look at and kind of go, that's okay, that's it. So there's a fair amount of input that I've received both online and in person that has helped me to develop that. And I've also worked with people who have come to some outreach events, brought their own telescopes, and sometimes been frustrated with them or needed help, or even some of the people who may have had telescopes for a while, but aren't really sure what to point them at for an outreach event. So this list really applies to both people doing outreach as well as beginners, and I think it has broad appeal in that respect. So I have begun to develop this with the advent of my new website that I just began and had revamped in the last several months. There are a couple of dad jokes in some of my new content. I did a new video for how to align an equatorial mount when you can't see the pole star, because sometimes there's a building or a tree in the way. So you can look for that dad joke on that video when you find that on my YouTube channel. But basically, it comes down to helping people be successful with their telescopes, whatever size they are and under whatever conditions they are. And it's easy for people to look at the moon or Jupiter or Saturn or Mars because those are naked eye, and whether they have a poor finder scope or even a red dot finder, it's usually fairly easy to aim most any telescope at those objects, find them, look at them. But then the question becomes, now what? Mm-hmm. And that, I think, is the question that I would like to answer with that list, is to say, here's how you can find great objects in the night sky that are worth looking at, that look impressive even through a small telescope and hopefully through light pollution. Now, that's not to say that you will necessarily be able to see these with the smallest of telescopes through the light pollution of, say, the Loop in downtown Chicago or Times Square, New York City. Those are obviously extremely awful conditions to try to see through. But it is possible to go to some place like even the Adler, which is not far from the Loop, and see stars that are dim enough to be able to star hop to some great objects and still be able to see those objects adequately to hopefully get people interested in either wanting to pursue astronomy more with either a better telescope, or perhaps trying to escape some light pollution, or better yet, doing something about light pollution and trying to reduce that problem that oh yes, exactly. Here, indeed. So very often what we hear, unfortunately, is start with the Messier list to those beginners. And I think that might be a mistake now. And that's just because there's a number of objects on there that aren't necessarily great to start with. So while start with the Messier list was probably very good advice a number of decades ago when people were making their own telescopes and they had larger instruments and there was, crucially, less light pollution to look through, that was probably fine. But nowadays we have ever more light pollution, unfortunately, and the telescopes have not gotten any larger. And so those of us who have done this for a while know that aperture rules very often, especially if you don't have dark skies to look at something, when it's a deep sky object that you want to see more detail in. So starting with the Messier list, it has sort of become a default just because there really wasn't anything else to go to. And that's not that there aren't people with good advice, because I have seen that good advice, particularly on Facebook. There's a number of Facebook groups where people will say, hey, I've looked at these bright planets and the moon. Now what do I look at? And people will inevitably list a number of great objects to start with. What I think gets missed, unfortunately, is that not only do you need to be able to see the object, you also need to be able to start at an object that's close by enough, so a bright enough star that you can then find said object. So for example, if someone said start with the Messier list and someone didn't know any better, they might say, all right, let's begin at the beginning. And they start with the Crab Nebula, and they might look for a photo of it and say, that's really cool. I want to see that. Which it does look impressive with a Hubble Space Telescope photo, or even photos that we take, because holy cow, the cameras that we've got now are amazing compared to what they were even 10, 15 years ago. But as those of us who have looked at the crab know, especially if you're not under dark skies, there's not a lot to see. So this sketch over on the right-hand side of your screen shows where the crab is. And I'm not sure if you can see my mouse cursor, but that's where it's showing the Crab Nebula is. There's just a little faint smudge there. So a new amateur astronomer, like just getting going, saying, oh, well, I can't see that, and I'm supposed to say that's exciting. There are so many better options that I think that we could pursue, rather than having people start out with something that may not look impressive and then they would give it up. So we need to also think about how some of these catalogs were started that we are recommending people to perhaps start with. Now, the new general catalog was new in 1888. And it was also not very new anymore. And it was really an extension of the work that William and Caroline Herschel had done, but it was also compiled by many different observers using many different instruments, providing their own written notes of where these objects were. So some of them were duplicates, some of them were never found when the list was updated and tried to be revised over the years. But it was never meant to be a, hey, this is great for amateur astronomers, especially to look through light pollution with a small telescope. So that's not necessarily a good one to begin with. And there's also, some almost 8,000 objects. And when we say start with the Messier list, let's think about what the Messier list actually was. Charles Messier was not a royal astronomer, so he was not trying to do any specific timekeeping for the monarch or government at the time. He was just a wealthy gentleman who wanted to be able to discover comets and say that he had discovered comets. So he commissioned a number of telescopes, he started looking in the sky, and then he kept finding things that looked like comets but didn't move. And for anyone who has looked for a comet in the night sky, whether it's naked eye or one that is needs a telescope, they move because as they're orbiting the sun, they move relative to the stars. So he kept finding these objects that didn't move that looked like comets. And we are telling beginners, look for these things that kind of look like comets that don't move, which to me doesn't necessarily make a lot of sense. And that's not to say that there aren't good Messier objects to look at, because there certainly are. There are some very bright ones that I will share in a few slides that are close enough to bright stars that amateur astronomers and beginners should absolutely look at first, because they're just they become objects that are almost like old friends to us. We keep going back to them repeatedly. So they should be some of the first ones that we start with. But there's other ones that are just not close to bright stars, or they're very dim, difficult smudges, or without a filter or a large enough telescope, impossible or next to impossible to see through light pollution. So I think we should start with some of the better objects. So something like this. This is the double cluster in Perseus. And it was certainly not something that Messier would have confused for a comet, because he would have seen lots of points there and said, oh, well, that's stars, so that's not a comet, because he was looking for comets. So it's not one of those objects that would have been, oh, this is a great beginner amateur list, or something that's good for outreach type of list, so we should include that on said list. And another one is this one here, which many of you may recognize, known as NGC 457, which is not the most the prettiest term necessarily, but because we very often see two eyes right here and a body right here and perhaps arms or maybe wings, this can either be known as the ET cluster or the dragonfly cluster or the owl cluster, as astronomy editor Dave Eicher once termed it. So this looks like something that is definitely interesting. And again, Messier wouldn't have confused that for a comet at all, but this is a great object to see, and it's in Cassiopeia near a bright star, very easy to find. We should be directing beginners to this, and if we're doing outreach, it's certainly an object that's easy enough for the rest of us to be able to find and show where it's interesting for people to look at, because they can say, yes, I can identify with that. Oh, yes, I see an owl or a dragonfly, or if they're old enough, they may remember ET. So back to the good Messiers, absolutely. Let's highlight some of the most impressive of the globular clusters and the brightest of the nebulae that are out there, and especially open clusters such as M11, this one in the middle. Those are not only bright and impressive to see, they're also close to those bright stars that punch through the light pollution that people can start their journey from, hop to them, and be able to see those. What I would term not great Messiers are some that may be good but aren't near bright stars. Messier 3 is probably one of the better globular clusters to see, but the problem is that it's not close to a really bright star. You have to go a good 10, 11 degrees from Arcturus to be able to find that. And if you're using a inexpensive plastic lens 5x24 finder scope, you might have a difficult time hopping your way across a number of dimmer stars to be able to find that wonderful globular. Messier 5 is another similar globular cluster like that. Messier 16 is an amazing nebula to be able to see. The problem is it has very low surface brightness. So without an appropriate filter for it, or enough aperture, or dark skies, or all three of those things, that would potentially be a very frustrating object for someone with a small telescope just starting out to be able to see. And Messier 33, I've got a personal story on this one. I tried for years to find that particular galaxy, not really understanding how large it was, and I had not yet understood how to calculate the field of view that I was seeing through my telescope. And so I didn't realize that the entire galaxy was larger than the field of view that I was even able to get with the telescope I had at the time and the eyepiece I was using, because it was a 25 millimeter Kellner through an f10 8-inch Schmidt Cassegrain. So as most of you know, that would be maybe a 1 degree field of view or so, and M33 is a little larger than that. And it's also spread out and dim. So that becomes a frustrating one to find and see. Messier 51 and M101 are lovely in photos, but they're also difficult objects to try and track down through a small telescope and through the light pollution side of things. So let's talk about light pollution a bit, because I think that if we get more people finding some objects that are fascinating for them to see, that they're excited about, that they can see through a small telescope from 60, 70, or 114 millimeters, they might, or at least we can encourage them to be more attuned to the issue of light pollution, turn off their outdoor lights, recognize that, hey, we don't necessarily need these lights on all the time, maybe start fully shielding them if they are updating their lights, using the lower color temperature so we don't get as much of the light scatter from some of the bluer LEDs that are out there now, or just turning off their lights entirely, because most of the time we really don't need the lights. And I have started a website called darkernights.org that really focuses a little bit more on the sleep side of things, because while we all, I think, want to see what's up there in the night sky, the issue I have often run into whenever I bring that up to anyone who's not interested in astronomy is they say, I don't care. You drive out to the country. I shouldn't have to turn off my lights. So if we make it about sleep, not only does it become an outdoor issue, it also becomes one that people recognize as a problem inside using their own lights, because if it's their own sleep that's affected from inside and outdoor light, then that's something that we can start to have a better conversation. And given that 30% of Americans indicate that they get poor sleep at some point during the year, I think we've got a real opportunity using that issue to make a larger impact on a much broader audience than our own. But that's a way that we can then help to be able to see things in the night sky for light pollution, and then that becomes icing on the cake for everyone else and a net win for us. And I think a net win really for everyone if they're getting better sleep too, and they can leave their curtains open and their windows open on a hot summer night rather than having to run an air conditioner and blinds down and curtains closed because light is pouring through their window.
Yep.
So here's what I did to create a better beginner list. One of the criteria was obviously it needs to be visible through a small telescope. Larger is not the issue, but it needs to be able to be seen something through 60 or 70 millimeters or so. I can recall getting some books when I was starting out, and a lot of them would start out and say, oh yeah, you can see this through a small telescope. And then as I would get further into the book, I'd say, well, you really need a 6-inch telescope for this, or oh, you really need a 10-inch telescope for that. And I'm sitting there going, I got a 50 millimeter telescope. I'm not going to be able to see any of these. So I want all these to be visible through a small telescope and look impressive through that, or at least visible enough that they go, hey, maybe I want to buy a bigger telescope, but at least seen and not just be a smudge. The other thing is that I wanted it to be within 7 to 8 degrees of a 3.5 magnitude or brighter star. And that does two things. One, it keeps it nearly within a finder scope field of view, because most finder scopes have about a 7-degree field of view. So if you only have to move at most maybe a degree or so outside of your 3.5 magnitude star, you have a good opportunity of being able to find the object that you're trying to see. And by focusing on a 3.5 magnitude or brighter star, what I did is said, all right, there's 9,095 naked eye stars that are visible across the entire celestial sphere, both north and south hemispheres, celestial hemispheres. Obviously, we can't see all those, but we see a lot of them as the Earth revolves around the sun. But by focusing on 3.5 magnitude, that reduces that total number to the brightest 3% of the stars. So the top 283 visible stars, which means that even under light pollution, people should be able to find and see these. And I kind of did a test with this where I was at Adler Planetarium, because I've been working on this list for years. I was at Adler Planetarium. You could see the loop. There were lights on at Adler, but I could look up and I could see stars that are that bright, naked eye. And because of that, that gave me hope that we would be able to at least get people to, even if they can't do it from a place like the loop, they can at least go to some place that's a little darker, maybe block some of those light trespass type situations and get away from light directly at them and be able to see enough stars that they can then start finding some objects. And then the objects themselves needed to be a magnitude 9 or brighter. And that might be pushing it a little bit, but we've only got so many to work with. So the magnitude 9 really applies to not necessarily being able to see all of, Messier 31 necessarily, but the core is very bright on that particular object, and it actually, at an integrated magnitude, has magnitude almost 4, so it's quite bright. And I tried to make sure that magnitude 9 meant that it still had some measure of visibility that people would be able to see it. So I looked at all these through small telescopes so that I was ensuring that these were good objects to look at. Now, I recognize that not every beginner, when they start out, necessarily knows the entire sky. And as a result of that, despite the fact that we have wonderful apps on our phones now that we can just hold them up and find all kinds of objects in the sky and saying, oh, I see where Jupiter's at, I know where it is. A lot of people do want to learn navigating the sky on their own. So I also tried to keep these objects close to 6 very distinctive, bright, and easily identified shapes in the sky. So I went with Cassiopeia and the Big Dipper in the north, and those are largely second magnitude stars that direction. The summer triangle, which is composed of first magnitude or brighter stars. The Great Square of Pegasus, which is second magnitude stars. And then Orion in the winter part of the sky, which is very bright stars, first and second magnitude. And then the Teapot in Sagittarius, which is a distinctive asterism within the larger Sagittarius constellation. And that would help people be able to look at a shape, identify it, and then know what direction they need to go from that shape to find their jump off point star for the star hop that they needed to perform to find the specific object that they're looking for. So I've got 6 videos that are on my website and also on my YouTube channel that go through that. So anyone that doesn't know how to find, even get started in the sky, those will help you get started. They're not long videos. They're about 5 minutes long each. So in half an hour, you can be a lot better versed in learning the night sky. And they're also bright enough that just about anyone can find them. And the telescopes on the sky list itself includes a wide variety of types of objects. So yes, there's only one galaxy because Messier 31 is just the brightest one and close enough to brightest star, but at least represents the galaxy class of things. And if people are interested in that, then larger telescopes and darker skies will help there. There's a variable star, which is also quite a colorful one. So that is something that people can learn about is in terms of the science of astronomy and understand the color temperature and how stars can pulsate over time. There are 4 nebula, and granted, nebula are like galaxies, are not necessarily the brightest, but there are some fairly bright ones that we can see through light pollution and with small telescopes with a little bit of work. Globular clusters are a little bit on the lower end as well because I even tried to find Messier 68 through my fairly dark skies down here one time with a small telescope and could not see it at all. So I've definitely gone with the very bright, amazing, great globular clusters that are close to bright jumping off point stars. And then I've included double stars, which you don't see on the Messier list or even in the NGC catalog because there are great double stars for people to be able to find and look at. And we show these at outreach events. We show Alberia all the time and Mizar Alcor. There are other ones that are not just double stars, but even multiple stars, such as the Double Double or New Scorpii, that are fascinating for people to be able to look at and find and see how much of those that they can see too. So that can help improve someone's observational skills. By looking at, say, the Double Double, for example, they might be able to split the 2 major components. And if they can't split the 2 smaller ones, then they recognize either I need better optics or maybe it just needs to be a better night. They start learning about how turbulence in the atmosphere can affect what they see. So that's one way that we can teach people about observing techniques as well. And then the last one is there's open clusters, and that the list is obviously quite heavy on those because those are the objects that tend to punch through light pollution the best, like the double stars do. So 28 of the 40 objects are of those the ones that I think are going to really be easiest for people to see through light pollution and with a small telescope. So that's why it has most of those, but it also represents really everything in terms of the type of objects that are visible. So for the actual videos that I have started to make for these, I begin with a naked eye view. So people know where to get started, what constellation they're looking at, what part of the sky they're looking at. And I point out the important stars that they're going to need to identify to begin their star hop. So for example, in this case, this would be for the double cluster. I always start at Navi and Delta Cassiopeia and then move towards the larger Perseus constellation, and then I show how people can find that and point out where the object actually is located, and then show a magnified view of what a representation of what it would look like through a telescopic view for that particular object. Now, there's 2 different ways to do a star hop because people today don't just have the magnified type finder scopes like the 5x24s. A lot of telescope manufacturers are making telescopes that only have the red dot finders on them to start. So what I also had to account for when I was making my list was, how can I make this list as broad as possible so that it includes as many objects as possible that people can find easily with a red dot or zero power type of finder. So 33 of the 40 objects that I've got allow the user to be able to find them fairly easily using a zero power type of finder. Sorry about the other 7. I had to make some hard choices there, but I think having 82% of them as options for people to be able to find was a pretty good percentage for that. So I show both the magnified finder scope star hop, and I even show it reversed field so that people can match what that field is likely to look like in their finder scope view, and show how the stars will move and how it will look. And then I also show what, if there's a red dot finder star hop to be made as well that's easy to do, then I show that as well, and where their red dot should be relative to the stars that they would be looking at in the sky. I've also made pages on my updated website that not just have the videos on them, but give a lot more information for people, because I didn't want the videos to be ridiculously long. Most of the videos are only about 4 or 5 minutes long, so that way someone can just use them outside to be able to find what they are trying to locate. But on the pages, there's, I think, helpful information for someone who wants to know more. So there's the link to the sky shapes, in case someone does not know where they need to even get oriented in the sky for the very beginners. I also include some observing tricks and tips. If someone maybe needs to use a filter, they may want to know if they, purchasing, for example, an oxygen 3 filter might help them to be able to see more, or even just using averted vision, which doesn't require any additional equipment, just it's a different technique that many of us who are veterans understand how to do to be able to see some more detail at the telescope eyepiece. I've also included sketches of how these objects look, and I think that's an important way to help people understand what they are likely to see. It may not be exactly what they see, and that's why I've tried to include multiple sketches from different people, so that there are objects that people can understand how it looks under different conditions, through different eyes, through different telescopes, and under different light pollution or whatever else. So knowing all those different aspects of it and saying, oh, okay, this is how it looks through a small telescope, here's how it looks through a larger telescope, at least it's not trying to say, look at this amazing Hubble Space Telescope photo that's got stars down to 16th or 17th or 18th magnitude. It's showing a little bit better representation of what they might expect to see when they look through their eyepiece. I also include details about the object itself, so how far away it is, perhaps how many light years across it is, what the angular distance is, so people can understand, what type of eyepiece they might want to use with their telescope. And then there's information about the constellation itself, and I list some of the brighter stars and a little bit of details about those too, so people can start to understand more about the sky and the area of the sky that they're looking at that particular object in, so they can have a deeper knowledge of the entire sky above them. And lastly, there's of course other objects that they can go to after they've completed that object and learned all about it. There's some nearby objects for that particular telescopes on the sky object. Now, I am very new into this. These take a lot of time to create. Just the videos alone, I'm spending anywhere from 6 to 8 hours per video by the time I write the script and do all my research, record it, and then edit it so that everything makes sense and it's clear. So I have about 6 done right now, and as I continue to add them, then people are welcome to go through them. Anyone who's a veteran, of course, can just go look at the list, and I'll show where to find that on my website in just a moment. So if you go to the tutorial section of my website, you'll just scroll down to the finding objects. If you're using a handheld device, there's the little hamburger thing with the 3 lines. You can click on that, go to tutorials and the finding objects, and then the telescopes on the sky link is towards the top there. But there's other ways to find it. From the home page, if you scroll down about halfway down the page, there's a section that has some of my more popular sections of the site. The telescopes on the sky list is in there. And then on every single page of the site, if you scroll all the way to the bottom, the telescopes on the sky list is also linked there as well. So it's easy to find. And they are also on my YouTube channel. So if you go to YouTube and look at my playlists section, although I'm releasing these over time, if you go to the playlist, then they're just all listed there. And I'm trying to do these all in order of right ascension. So we've started with Messier 31, and we'll go through some of the winter objects, hit spring, and finish with the ones for summer and fall. And if anyone has any questions, please feel free to reach out to me on Twitter at Astronomy Dave, or on Facebook. You can just search for Eyes on the Sky and look for this little symbol, because I think there's a couple different Eyes on the Sky Facebook pages. So mine would obviously have the little moon in the galaxy type shape there, and that's how you would be able to find me. And then I will finish with what I think is on a lot of people's minds for the next couple of days anyway, the Great Conjunction that's coming up on December 21st. Jim did ask me to mention a little bit about this. This view that you see over on the right-hand side of the screen is how close the planets should appear to each other on the 21st in the evening. Right now, I'm not seeing good weather forecasts for Monday, unfortunately. So we may not see this, unfortunately. But this is a photo that I took about 2.5 hours ago. And they are getting closer to each other. So this may be difficult to see, but I did manage to capture a couple of the moons of Jupiter here, and you can see the rings of Saturn maybe if you're looking on a screen that's large enough to be able to see that. I did post this on Twitter and to Facebook. So if you do catch me on either of those spots, you would be able to see that in a larger view as well. But this is the one that we're hoping for. Sunday night, they will be close. Saturn's gonna be a little further away, but right now, these should be visible in a medium to low power eyepiece field of view without any difficulty. So I would definitely encourage anyone who has a telescope, point at Jupiter about a half hour after sunset, and catch these two planets like this, because this will not happen again until March 15th, 2080. So we have a couple of years to wait until this will happen again. And if you don't get a chance on the 21st, look on the 22nd, 23rd, 24th. I did a number of videos on these just recently, both how to see them through a telescope, in addition to how to try and photograph them with various cameras, whether you're trying to use a DSLR or a dedicated astro camera, because I know people are definitely interested in trying to image these if possible, as well as I tried to capture here. It's not easy. The brightness difference between Saturn and Jupiter is 11 times, if I've done my math correctly on that, which means that one of them is either too bright, like Jupiter, but you might get some of the moons, and then the detail on Saturn shows up, or you either, if you get any detail on Jupiter, then Saturn is pretty dim and difficult to see, and then you don't get any moons. So if you're trying to do anything, you may have to do a composite image if possible. But that then covers everything. And if I will open it up to questions, if anyone has any, and I will be happy to field those.
So Dave, where in the sky should we be looking for Jupiter and Saturn? West, southwest?
Jupiter and Saturn right now are in the southwest sky. Yes, so definitely about a half hour after sunset. I went outside this evening 20 minutes after sunset, and I could not locate Jupiter for the life of me, and I tried very hard. And I'm pretty good at finding things in the daytime sky when they're visible. So I would definitely say 30 minutes after sunset towards the southwest, and Jupiter will be the brightest thing that direction. So look for that.
Okay.
There was one question from the chat, I think right at the beginning of your talk, and it was very related to what you were just talking about, so it might have been answered already in that. But Malik had asked, what do you recommend for viewing the planets during that conjunction on December 21st? Is there a special scope or anything?
Any telescope that you have, the larger the better, I would say, and then whatever magnification you have available to you that still frames the planets adequately without putting them way on either side of the field of view. So because they will be 1/10 of 1 degree apart on Monday, which we may not see. They're not that much further apart even on Sunday. So for most people, if you are getting them in a half to 2/3 of a degree field of view, telescopic field of view, you should be fine to get both of them there, particularly if you have a mount that is tracking the night sky and accounting for Earth's rotation. If you don't have that, I'd go with something wider so that you can manually track. Does anyone else have any other questions as far as either the conjunction itself, which I'm happy to talk about, or the telescopes on the sky list?
Dave, where
Yes.
in Connecticut would we see the conjunction? You said it's in the southwest sky, but is it low toward the horizon or up a bit, for instance?
It will be, it's going to depend on the time of night. And that's the hard thing, is because just like the sun sets, the planets are going to set eventually too. So the longer you wait, the lower they will be. The earlier you're able to spot them, the higher up they will be. For the latitude you're at and where we are here in Chicago, we're at about 40-ish degrees latitude. So they are approximately 15 degrees up. So here's an easy way to do that. You hold your hand out like this, put your pointer finger and your pinky out like that at arm's length, and that's about 15 degrees. And
Okay.
they might be only 10 degrees, so you might actually need to hold it like this. And 10 degrees is a fist width across. So look between 10 and 15 degrees above the horizon to the southwest after sunset, and that should be about how high they are. They're going to get lower, obviously, as the Earth rotates. So later is going to be lower, but they are also brighter then. So it's a matter of kind of juggling those two competing issues.
Right, and dealing with the light pollution, which we have here too.
Correct. Light pollution, although they're bright enough that they both punch through light pollution fairly well, even through our Chicago skies, they will be visible too.
Okay, if it's clear here on Sunday and Monday, Mom and I will take a try at it. Thank you.
All right, go up to the grade school. That probably is your, as I recall.
A better
What's
place
that?
might be at the top of Snake Hill up by the farms, because that's
Yes,
higher
that
than
would be a
grade
good spot
school.
too. Yes, that get up on a hill. That definitely, and for anyone here in the Chicago area that has trees around or buildings or anything else, they would definitely want to go somewhere that they are away from any type of obstruction towards the southwest.
Right. Thank you. Appreciate it, Dave.
You're welcome.
Dave, how many different videos do you have posted to Eyes on the Sky?
Oh goodness. I think there's about 400 or so at the moment. Most of them have tried to focus on what's visible at a specific time of year on a specific year. So if the planets are doing something that's interesting, or the moon is nearby, or if there's an asteroid that's visible, I've tried to focus a lot on those. But I do have a lot of other deep sky object videos too, which are fairly I've even got some playlists that have a lot of those sorted. So there's a autumn playlist and a winter playlist that would be certainly a good options to look at. And then I have some other telescope specific videos where I talk about some telescope basics. So anyone who does not know the first thing about telescopes, in like 35 minutes, you'll be way up to speed on understanding the types, eyepieces, what to do with your finder scope, how to calculate that telescopic field of view that I struggled with for years before I understood how to do that, and be able to get going with the telescope quickly. And then I've got 3 short stargazing basics videos that also kind of tie in with those shapes in the sky videos, so that people understand just basics of like star magnitudes and those measurements in the sky, as well as just getting oriented.
So they're geared toward the amateur.
Definitely, most definitely. I try to keep it so that anyone can start and be able to find things if they, no matter what type of equipment they use. And sometimes I'll even just do naked eye and binocular type issues as well, just depending on what's up there in the sky. But I try to keep it so that it's at a level that anyone can do it.
Well, you know, especially considering the times that we are in, I'm going to, you know, send out a notice to, you know, all CAS members and, you know, others who are on the mailing list to visit your YouTube site periodically. So we have something to do.
I did.
Something to educate us, at least, you know, over the ensuing months.
I did just post a link to the Eyes on the Sky YouTube channel in the chat. So
Oh,
please,
thank you.
everyone click on that, subscribe to his channel. Yeah, so that's in there in the chat.
Thank you so much. I appreciate you doing that. And if anyone has questions on some of those videos, I try very hard to make sure I respond to most comments on YouTube as well. So if someone says, hey, you know, I don't quite understand this section, please, you know, post something and I will very likely answer it. The only ones I really don't answer are the ones where people start to talk about astrology stuff. And then I just say, nope, no, I'm not going to talk about the sign of Aquarius or whatever.
All right. Do we have any further questions? Wow. Well, I can't thank you enough, Dave. I'll be getting back to you. And we don't have a speaker lined up for next month, but we're working on it. And as soon as we get something, we'll put the bite on Wayne and Chris at Cernan to set something up for us. And in the meantime, you know, Merry Christmas to everybody.
Merry Christmas, everyone. Thanks for tuning in with me.
Thank you very much. Great.
Yeah.
Thank you.
You so much. Just so everyone knows, this video will be posted onto the Cernan YouTube channel as soon as I am able to get it downloaded and edited together, so you can find it there. And feel free to share that with anyone who missed tonight's talk. I know there are a couple people who were trying to connect and having trouble. So just go ahead and direct them to the YouTube page. It will be up there hopefully next week.
Thanks for your time, David.
Yeah.
Thank you for having
Bye-bye.
me. And everyone have a nice evening and enjoy your weekend. And look for
Okay.
the conjunction.